Standard deviation of a discrete random variable. Our objective, we want to compute the standard deviation of a discrete random variable. Let's, of course, review before we begin a couple things that we know. We know what a discrete random variable is. It is a random variable that has either a finite or a countable number of values. The word discrete tells us that. And we know what standard deviation is. It's a measure of how spread out the numbers are. So how do we calculate the standard deviation? Okay, shift this down a touch. Okay. The standard deviation of a discrete random variable is the square root of a weighted average of the squared deviations for which the weights are the probabilities. Whew. That's a mouthful of mathematical language. Okay, and here's our standard deviation symbol sigma sub x. Here's the square root. We're going to add up the squares of the difference between our data point and the mean. We're going to square that, and then we're going to multiply that by the probability of that particular data point. I'm going to write this out in our example here, just kind of do a little bit, but we are certainly going to use StatCrunch to come up with this number because this can take some time. But I'll kind of, in the example here, I'll list out the first few so you can see what's happening. Okay, but we're going to make use of StatCrunch to do this. So here's our example. We've seen this example before. The Sullivan Statistics Survey 1, which talks about how many televisions are in your household. All right, and we're talking about in StatCrunch 6.1.17. The random variable x represents the number of televisions. And so what we have here in the chart is the probability of having that number of televisions according to what they came up with. As a reminder, I think I'm straight. I'm kind of wondering if I am or not. As a reminder, the probability the household has one television from what they surveyed here was 0.161, which we know if we want to talk about it as a percent is 16.1%. Let's compute the standard deviation of this variable. How much spread is there? Well, it's right up here. There's that formula. Okay, so let's remember, because we need to know the mean. We need to know the mean right here. Let's remember we've already calculated the mean. The mean sub x was equal to 3.21. We did that in a previous video. We need to know the mean. It's not shown here, but we've already calculated it. We have the x's, they're here, and we have the probabilities, they're here. We just were missing this piece, but we've already calculated it. Okay, so the standard deviation is equal to the square root. Okay, I'm going to do a big old square root. Why not? Okay, of all this stuff, we're going to add up a bunch of things. Well, the first thing we're going to do is we're going to subtract our first value 0 minus the mean. We're going to square that and multiply it by the probability, which is also 0. So our first term is 0 minus 3.21, the quantity squared, times the probability, which is 0. This is our number of televisions. We start off with 0, 0 minus the mean, take the difference, square it, multiply that by the probability, and then we're going to add. This is the summation. Now we're going to add. Let's go to line 2. 1 minus 3.21, 1 television minus the mean, square the difference, and then multiply it by the probability. So you can see how this takes some time. Thank goodness for software. We'll continue. Plus 2 minus the mean, square the difference, multiply it by the probability. 3, 4, 5, 6, 7, 8. I'll go all the way out and I'll write down number 9. We finally get to number 9, the last of our addends. 9 minus the mean, square it, times the probability for having 9 televisions, which is 0.01. That's the mathematics behind it all. If you do all of this, I think round it to the thousandths, we come up with 1737. So the spread of the numbers is 1.7 televisions is the standard deviation. Okay, that's the spread. Let's do this using StatCrunch. Let's see if we get the same answer. Okay, come back here. We got 1737. I'm in StatCrunch. Let's get it to looks like it's clear, I think. Yep, all right. 6_117. Here's our data set. Number of televisions in column 1, the probability in column 2. We're going to go back to Stat. We're going to choose Calculators, and we're going to go down here toward the bottom and choose Custom. And we're going to do the same thing we did with the mean. Our values, which are the number of televisions, so we're going to choose that. The weights are the probabilities. Probabilities are also weights. What's the probability? What's the weight of something happening? And so that is our P of X. And then we'll simply press compute. Okay, so there's our distribution graph. Scroll down, and you can see here with the standard deviation, 1.7366347. So I approximated to the thousandths, 1.737. So that's how you calculate the standard deviation of a discrete random variable.